Hello everyone, myself Mrs. Vidyanalaude. Today we are going to start our last topic from the syllabus, aliphatic amines. This chapter contains various points of introduction, nomenclature, methods of preparation, reaction, basis of amine, and structure and uses of various aliphatic amines. So let's start with the introduction. The name of topic is aliphatic amine. So everyone knows what do you mean by aliphatic and aromatic compounds. Aliphatic compounds are those compounds which contain straight chain in their structure, and aromatic compounds are those which contain ring in the structure, and generally this ring is related to the benzene like ring. So our topic of focus is only the aliphatic amine. Okay, so now what do you mean by the amine? Amines are the organic bases which are structurally related to the inorganic base ammonia. Okay, so for that purpose you should first know what is the structure of ammonia. Okay, so as you can see, this is the structure of ammonia, in which centrally placed nitrogen to which 3 hydrogen atoms are directly attached. Now, as amines are derivative of ammonia, in which 1, 2 or all the 3 hydrogen have been replaced by the alkyl group. And remember, these alkyl groups are directly attached to this nitrogen atom. So, we can compare these two structures. This is the structure in which 1 hydrogen from the ammonia get replaced by the 1 alkyl group. In this structure, 2 hydrogen from the ammonia get replaced by the 2 alkyl group, and in the third structure, all the 3 hydrogen, these hydrogen from the ammonia replaced by these 3 methyl groups. So amines are derivative of ammonia, in which all the 3 hydrogen or 1 or 2 hydrogen get replaced by the alkyl groups. So next is the classification of amine. Amines are classified into 3 types depending on number of alkyl group directly attaches to the nitrogen. So 3 types are primary, secondary and tertiary. In primary amine, 1 alkyl group directly attached to the nitrogen atom. Secondary amine, 2 alkyl group directly attached to the nitrogen atom. And in the tertiary amine, 3 alkyl group directly attached to the nitrogen atom. As here we can see the chart which contain the class, general formula and functional group. So first type is the primary amine. The general formula is RNH2. So in case of primary amine, only 1 alkyl group directly attached to the nitrogen and remaining 2 are hydrogen. So the formula is RNH2, and here functional group present is NH2 called as amino. In the secondary amine, 2 alkyl group attaches to the nitrogen along with the 1 hydrogen. So the general formula is R2NH, and the functional group NH is called as imino. Now in the tertiary amine, general formula is NR3. Okay, so 3 alkyl groups attaches to the nitrogen, so that's why it is R3N, and this functional group N is the tertiary nitrogen atom. Now in case of secondary and tertiary amine, whatever the alkyl group attaches to the nitrogen may be same or different. So as we can see in this structure, see, this is the first structure in which 2 alkyl group attaches to the nitrogen are same. First is R, second is R. But in this structure, these 2 alkyl groups are different. This first one is R and second one is the R dash. So if whatever the alkyl group attaches to the nitrogen are same, they are called as simple amine, and if the alkyl group attaches to the nitrogen are different, then it is called as mixed amine. Next is the nomenclature system for the aliphatic amine. As all we know, there are two systems, common name system and IUPAC system. So first we'll see the common name system. So whenever we see the structure of compound which contain NH2 as the functional group, and for that compound if we want to write down the common name, then you have to first identify and write down the name of alkyl group present in the structure, and then after the alkyl group you have to add the suffix amine. So now you will get the name of that respective compound. So let's elaborate with the help of example. See, this is the first example. The structure is CH3NH2. So as per the rule, we have to identify the alkyl group which is present in the structure. So it is CH3. So what is the name of this alkyl group CH3? So the name of group is methyl. Yes. So methyl we have to write down, and after methyl we have to add the suffix NH2. So the name of compound is the methyl amine. Same way you have to tell the name of this second structure, CH3CH2NH2. So identify the alkyl group. Yes, yes, it is the ethyl. Now after ethyl you have to add the suffix amine, so it will be the ethyl amine. Same way this is the N-propyl amine, this is isopropyl amine, tertiary butyl amine, dimethyl amine, trimethylamine, methyl ethylamine, then dimethyl ethylamine, and last is methyl ethyl isopropyl amine. Okay, now next is the IUPAC system. So IUPAC system of amine is generally applicable for long chain substituted amine, and in this system we have to consider whatever the structure of compound which contain the amino group whole as a amino alkane, and in this system you have to select first the longest continuous chain of hydrocarbon which contains the functional group. Then position of this chain is indicated by the Arabic numericals, means 1, 2, 3 and 4. Then give the numbering in such a way that whatever the carbon bearing the functional group should get the lowest possible number. Okay, so what to do? First select the longest continuous chain which contain the functional group. Then you have to give the numbering to the chain so that the carbon which contain the functional group should get the lowest possible number. So let's see the example. We will see the simple example. See, this is the first structure which contain the straight chain along with the functional group NH2. So we will select this as a longest continuous chain of hydrocarbon. Then we have to number in such a way that this carbon which bears the functional group should get the lowest possible number. So that's why we will start the numbering from the right side. See, this is the right side, 1, 2, 3. So at the first position functional group amino is present, so that's why we have written 1 amino and 3 carbon containing alkane, that is the propane. So here we have write 1 amino propane. Okay, because in the rule we have seen that the whole whatever the structure of aliphatic amine we have to consider as amino alkane. So it will be 1 amino propane. Then next is the C. This is the longest continuous chain. At the first position amino group is present, second methyl group. So it will be 1 amino 2 methyl propane. Then third structure. in the third structure, again longest continuous chain of 5 carbon, at second position amino group, third position methyl group. So it will be 2 amino 3 methyl pentane. Then further, if the amino group contains alkyl group as substituent, the word N-alkyl or N-dialkyl is prefixed to the word amino. Means what? See, this is the first structure. In this longest continuous chain, to the functional group, one alkyl group is attaches as a substituent. So in this case, we have to use the word N-alkyl or N-dialkyl. So in this case, only one alkyl group is attached to the functional group of NH. So here we have to use N-methyl. See, this is the longest continuous chain. 1, 2, 3, 4. At the first position, amino group is added. So we have written 1 here. Then N-methyl, because to this nitrogen methyl group is present, N-methyl, this amino, and 4 carbon containing alkane, that is the butane. So it will be 1 N-methyl amino butane. So in the next structure, this is the N, that is the functional group amino. To these 2 methyl groups, that are the alkyl groups, are present. So here is written N-dimethyl amino heptane. Why heptane now? Because it contains 7 carbon chain. So this rule is applicable if the amino group to which if alkyl groups are attached as a substituent. So now next is the methods of preparation of aliphatic amine, in which first method is reaction of alkyl halide. So what happened in this alkyl halide? Alkyl halide on treatment with excess of ammonia produces alkyl ammonium salt, and this salt on further treatment with the base results into production of primary amine. So now let's see the reaction. Everyone knows the general formula for alkyl halide? Yes, it is RX. Reacted with the excess of ammonia produces alkyl ammonium halide, which on further treatment with NaOH produces primary amine along with the NaX and water. Okay, so now as we can see, whatever the electron present in this bond of alkyl halide goes with the X, and these two structure gets combined together to form the alkyl ammonium halide, which on further treatment with sodium hydroxide, in this second step, this halide goes with the sodium, and whatever one hydrogen from this structure transferred to this OH and produces water. So here we will get the primary amine plus sodium halide and plus water. So let's see the example. Now here CH3CH2Br ethyl bromide react with the ammonia to produce the ethyl ammonium bromide, which on further treatment with NaOH produces the ethyl amine. Now, next reaction is reaction of alcohol with ammonia. In this reaction, excess of ammonia plus vapors of methanol are passed over a dehydrating catalyst. Dehydrating catalyst we can use thiourea or alumina at the temperature of 300 to 400, and there is production of methyl amine, that is the primary amine production takes place. This reaction does not stop here. This primary amine again react with second molecule of methanol under same temperature condition, produces dimethylamine, which on further treatment with the methanol under similar condition produces the trimethylamine. So it is the continuous reaction which does not stop at the first step. So these are the first two reactions, means methods of preparation of aliphatic amine.